Welcome to my lesson over our theorems in arcs and chords. We're going to start off going over 3 theorems that you're going to see us use down below to solve. So we're going to start off here with the first one that is stating that in a circle or in congruent circles, 2 minor arcs, so less than 180 degrees, are going to be congruent if and only if their corresponding chords are going to be congruent. So here we are going to say that, if we know that the measure of these 2 arcs are going to be equal, so looking at it, that would be from A all the way over here to that B. This arc is congruent to from C all the way to D. Then I can safely assume that my chords that are corresponding with that should be congruent. So these 2 segments from A to B would be congruent to C to D. Now, moving into our next theorem, okay, we've got 3 different ways of writing 3 different things they might be giving you and what you're able to come up with from it, but they're pretty much all stating the same things. So if we have a diameter is perpendicular to a chord, then it should bisect the chord and its arc. Okay, so here we have that if we have a diameter, so a segment that's going to go through the center, okay, to have endpoints on the circle, is going to be perpendicular, so that's why we've got this box here. Then it should be cutting in half the chord so that these 2 segments are congruent from C to D and D to B, as well as the arcs that are corresponding with them. Okay, so from CE to EB. Then we have if a diameter is going to bisect a chord, and to clarify, that chord should not be another diameter. So just to mention this, a diameter is going to have endpoints on the circle with it going through the center. A chord is just a segment that has 2 endpoints on the circle, but it doesn't specify it has to go through the center. So technically, the longest chord in a circle is your diameter. All right, so going back to this, if your diameter bisects a chord that is not another diameter, then it should be perpendicular to that chord. Okay, so here, if you happen to know that DC was congruent to DB, that chord was being bisected, then you could safely assume that it was going to be perpendicular to that chord. Lastly, we'll have in a circle, the perpendicular bisector of a chord is going to contain the center of your circle. So like I mentioned earlier, just different information, we're able to conclude the same stuff. So here, if we know that this is perpendicular and that these 2 segments are congruent, so that chord CB was bisected, then you're able to say that this segment that's going to do that should be either a radius or a diameter, since both of those segments go through the center. All right, and then lastly, we have in a circle or in congruent circles, 2 of the chords are going to be congruent if and only if they are equidistant, so the same distance from the center. So here, if we happen to know that from M, my center, to each of these chords, that it's the same distance, they're equidistant, then you can safely say that you'll know that the 2 chords from A all the way to B and C all the way to D should be congruent to each other. All right, so now we're going to take these theorems and we're going to apply them to solving these problems that they've asked us to find the answers for. All right, so starting off with number 1, we have in circle C, we are given that C to G is congruent to C to H, and that CG is going to be perpendicular to our segment AB, and that CH is going to be perpendicular to our segment DE. And we are given that from D all the way to E is going to be 24. We want to find AG. Okay, so this is going to kind of combine a few of the theorems I mentioned above. So since they are equidistant, so the same distance from the center, we know that A to B should have that same length of 24 as DE. And since we know that CG is perpendicular to that AB segment, that chord, and since it is going through the center, we are able to say that it should be a bisector of that chord. And so therefore, to find our AG, we can just take that 24 divided by 2 to get 12. All right, now let's move into number 2. So for number 2 here, we have that we're given that MN is congruent to NP, which is then congruent to PQ. We're also given that the measure of my arc MQ is 120 degrees. I want to find the measure of my arc from N to P. So what I'm going to do is I'm going to call this arc X, I'm trying to find. And if that's X, I then know all 3 of these arcs should also be that X. They are going to have the chords being congruent, so my arc should be congruent. So I can write an equation that says that 3x plus that 120 will be equal to my full circle of 360 degrees. Then I can subtract that 120 to get that my 3x is equal to 24. And when I divide, I get that my x is going to be 80. So since we're finding the measure of an arc in P, we need to have our degree symbol with that 80. All right, now let's look at number 3. So for number 3 here, we are given that OD is equal to 15 and CD is equal to 24. So let me label that here. If OD is going to be 15 and CD is going to be 24. We are asked to find from O to E, okay, I'm going to call that X. And then from E to G, I'll call that Y. All right, so in order to do this, we are going to apply the theorem that stated that here, since this is perpendicular and it goes to the center, we know that this chord is being bisected. And therefore, instead of using that 24, I'm going to use 12 for my length of ED. And I will notice that it is perpendicular. So I'm going to have that right triangle being formed. And as always, when you have a right triangle and 2 of the sides, you can use Pythagorean theorem. So we're going to start off by finding OE using Pythagorean theorem. So I'll have that x squared plus 12 squared is equal to 15 squared. When I square that, I'm going to get 144 and 225. So subtracting, I'll get x squared is going to be equal to 81. And when you take the square root of both sides, you should get that x is equal to 9. So my x was that OE, so technically OE is equal to 9 is what I want to write. All right. From that, we can move into finding that EG, which is the y that I labeled. Okay, and so what I'm going to use here is the fact that from O all the way to G, that whole line, that is a radius. It goes from the center to a point on the circle. And we did already mention earlier that it was given that OD was 15, and that happened to be a radius. So here, in order to find EG, I can take the length of my radius, which is 15, and subtract the part of it that I don't want, that OE, that 9, and I will be left with 6. So EG has a length of 6. All right, now let's move into number 4. Number 4, we are given that TR is equal to 9 and that EN is going to be equal to 10. Okay, so we have 9 and 10. All right, we do see that it is perpendicular, so I'm going to go ahead and right off the bat say that I can bisect this to get 5, half that 10. And we are asked to find RA. I'm going to call this X. Okay, so from R to A, I want to find that length. And so what I'm going to do is I'm going to create a right triangle, kind of like what we see in the previous problem. And that RE that I just drew is another radius, so I can use that same 9 that was given earlier. And now I can solve for X using Pythagorean theorem. So we'll have our X squared plus 5 squared is equal to 9 squared. When I square everything, I'm going to get 25 and 81. And when you subtract, you should get that X squared is going to be equal to 56. So therefore, taking the square root of both sides, this is not a perfect square, so I am going to need to break this down, simplify it, so that I can have my final answer. So here I could break it down into 2 and 28. And then I could have 2 and 14. And lastly, 2 and 7. So here I will have my pair of 2's. Since I don't have any other pairs, I'm going to multiply that 2 and 7 back together. And so therefore my X is equal to 2 root 14. And that's my RA, so I'm going to go ahead and just say RA is equal to 2 root 14. Okay, moving into our second to last problem. We are given that PQ is perpendicular to RM. Okay, so I'm going to label that. We have that PQ is perpendicular to that RM. And we are asked first off to find or name an arc that is congruent to that QR. Okay, so since this is perpendicular, remember this segment here from P to Q is a radius. And when that radius or diameter is perpendicular to a chord, it is going to bisect the chord and bisect the arc. Therefore, the arc QR is going to be congruent to my arc QM. Then we can move into part B, which is telling us that PR is 13 and RM is 24. I want to find PA. So here we would have that 13. Our M is 24, and so we did mention here that it's going to bisect, and so this should be 12. So to find that PA, I'm going to call that X. I'm going to use that Pythagorean theorem once again, and we will have my X squared plus 12 squared is equal to 13 squared. So squaring everything, we'll have X squared plus 144 is equal to 169. When I subtract, I'm going to get X squared is going to be equal to 25. And so I take the square root of both sides, and I should get that X is equal to 5. So my PA is going to have a length of 5. All right, last and final problem for these notes. We have, suppose a chord is 20 inches long and is 24 inches from the center of the circle. We want to find the length of the radius. So here they gave you a circle, but nothing else. So we're going to draw our own picture by starting off with a chord, just any chord. And they said that this is going to have a length of 20. So I'm going to write that this is 20 inches. And that it should be 24 inches from the center. Okay. And so we want to find the length of my radius. So I'm going to just draw a line here from the center to the end of that chord. And this is the length that we're going to find here, that radius. So when I drew that distance from the chord to the center, I drew it to be perpendicular, and therefore we are going to once again use Pythagorean theorem to solve. And we can use that length of 24 and half of that 20, which will give you 10 inches to find my X. So we'll have 10 squared plus 24 squared is equal to X squared. When we square everything, we're going to get 100 plus 576 is equal to that X squared. And when you add those two together, you should get 676. And we want to take the square root of that. So if you know the square root of 676, great. For those of you that don't, that is fine. Just make sure that you are trying to simplify before you write that as your final answer. Okay, so here this can be broken down, and we can divide by 2. So start off small if you're stuck. So when I divide by 2, I'm going to get 338. Then I could divide that again by 2, because it's even. And I'm going to get 169. Now that 169 I am very familiar with. I know that that is going to give me 13 and 13. And so I'll have a pair of 13s I'll pull out with a pair of 2s. And so we'll have 2 times that 13, which will give you 26. And therefore the radius is going to be equal to 26 inches. All right, and that is it for our lesson over our arcs and chord theorems.